If you are a VBA developer and are considering learning Python, then this video has everything you need to know. Let's jump in. The first thing we're going to look at is where the code is stored for both languages. The VBA code is saved directly in the workbook file. This makes it easy to access. Just open the workbook, press Alt plus F11 and you have access to the code. This setup is convenient, especially for non-programmers, but it does have a major drawback. Having the code embedded in the workbook makes tracking and updating all our code challenging. In programming, we use version control to help us track previous versions of code and to allow us to store code from all our projects in a centralized code database. This approach has many advantages. For instance, if we have code used across multiple projects, we only need a single centralized copy. We can set it to automatically integrate with any project. In VBA, however, updating shared code requires manually re-importing the module into each workbook where it is used. In Python, the code is stored in text files, but the file is named with a py extension. This is typical for most programming languages. The code is actually just a text file saved with a specific file extension to indicate the language. And these extensions help your computer recognize and run the code correctly, whether it's CS for C#, JS for JavaScript, or PY for Python. Having code stored in text files like this makes it very easy for us to use version control. Now let's take a look at the development environment. So that is how we write, edit and debug our code. The VBA editor is built directly into Excel, accessible with a quick press of Alt F11, and it's straightforward to use. However, since the editor hasn't seen a major update in over 20 years, it lacks many features available in modern development environments. There are some third-party tools like RubberDuck and MZ tools that add functionality to the VBA editor, but unfortunately there's no option to fully integrate VBA with a modern code editor. With Python, there's a wide range of code editors to choose from, with popular options including Visual Studio Code and PyCharm. These editors come with features which the VBA editor lacks. For example, customizable themes and layouts, including multiple dark themes, advanced IntelliSense for better code completion, collapsible code sections, and much more. But the biggest advantage of Visual Studio Code is its extensive library of extensions, and these allow you to add tools and features that enhance your coding experience. For example, the Python snippets extension is especially helpful for beginners, providing built-in code snippets which you can easily add to your code. In VBA, we can run code directly from the Visual Basic Editor, which is especially useful while writing and testing code. For regular use, macros are typically triggered by events like a button click or a worksheet event. In Python, code can run from either the editor or the command line. In a fully developed application, the way the code executes depends on the type of application. It might be triggered by a button click in a desktop app similar to VBA, or by a page load event in a web application. If we plan to give our application to other users, then we have to consider how we will distribute it. With VBA, this is straightforward, as you give someone the workbook and the code will simply run from within the workbook. This ease of distribution is so effective that VBA macros have been widely used to spread viruses, prompting Microsoft to implement automatic blocking for workbooks downloaded from the internet. For some users, one of the major drawbacks of VBA is that it doesn't allow you to fully protect your source code from users. Although you can set a password, it's relatively easy to bypass. So if you need stronger code protection, you'll need to rely on a third-party tool. Distributing Python applications requires a bit more planning than VBA. Here are some common approaches. There are a few ways to do it. Method 1. Install Python locally. The user can install Python on their machine, or you can provide a setup script to install the correct environment. Method 2. Create a standalone executable. You can package everything into an executable file so users don't need to install Python themselves, though these files can be large if they include many libraries. And method 3, use a shared network installation. Install Python in a shared network folder, allowing users to access it without installing Python on their own machines, provided network speed is sufficient. Now let's discuss platforms. In other words, where our application can run. VBA is primarily used on Windows, though it does run on Macs with limitations. Features like user forms and certain Windows libraries are not supported, and this makes it challenging to write code that is compatible with both platforms. Python, on the other hand, is fully cross-platform, meaning the same code can run on Windows, Apple Mac, Linux, and even in the cloud. Libraries are a big part of why Python is so popular. They offer pre-built solutions for almost anything, from data manipulation and machine learning to web scraping and scientific computing. One of the best known libraries is Pandas, which is widely used for data analysis. In comparison, the VBA library selection is poor. The most notable ones are ADO, WinHTTP and Scripting Runtime. Apart from these, however, there are very few useful libraries in comparison with the wide array of useful Python libraries. If you're a VBA developer, you might wonder, how does Python work with Excel? VBA makes it easy because it comes with the Excel object library. And this library lets you work directly with things like workbooks, worksheets and ranges using the Excel object model. Python works differently. To use Python inside Excel, you need third-party tools such as Excel Wings or Pixel. These tools let you run Python scripts in Excel. One advantage Python does have is that it can work on Excel files without opening the Excel application. There is a library called OpenPyXL, and this lets Python read, edit and save Excel files in the background. And this is very useful in a lot of scenarios. Now that we've explored how VBA and Python are used, let's see how writing the code compares in both languages. In VBA, we define a variable using dim followed by the variable type. For example, here we declare count as a long integer. First we declare the variable, and then on a separate line we assign it a value, in this case 0. In Python, creating a variable is much simpler. You just assign a value directly like this. This automatically creates an integer variable called count. This is known as dynamic typing. Python determines the type based on the assigned value. While this approach makes coding faster, it also means certain errors won't be caught until the code actually runs. Interestingly, you can skip declaring variable types in VBA as well. You do this by removing option explicit from the top of your module. Without option explicit, you don't need to declare variables or their types explicitly. However, I strongly recommend against this practice in VBA. Skipping variable declarations might save you a bit of time up front, but it can lead to hard to find errors later. In VBA, an if statement follows this structure. The if and then keywords surround the condition you're evaluating. If the condition is true, the code within the block will execute. The statement concludes with end if to indicate the end of the conditional block. In Python, the if statement is similar but simpler. Python uses colon to mark the start of the block and relies on indentation to define the scope of the code. There's no need for an explicit end keyword like end if. Just to be clear, if this code is indented, then it will run if the condition is true. If it is not indented, then it won't run. And this is important to understand because indentation in most languages is optional, but in Python it affects how the code runs. In VBA, we can extend an if statement with else and else if to handle additional conditions or a default case. In Python, the structure is very similar. However, instead of else if, Python uses elif. In VBA, we can use select case as an alternative to if statements. Python did not have any equivalent to this until the match statement was introduced in version 3.10. In VBA, we have two main types of for loops. Number one, we have the standard for loop. The standard for loop is ideal when you need a counter and precise control over the loop's order. In this example, we get a loop with a counter variable I, which we can use within the loop or to control the loop's range and direction. The second for loop in VBA is the for each loop. And this is specifically designed for iterating over data structures like arrays, collections, or dictionaries. The advantage of the for each loop is that it's cleaner to write and significantly faster for structures like collections compared to using a standard loop. In Python, the for loop works differently. A typical for loop might look like this. Here range 111 generates a sequence of numbers from 1 to 10. Note that the last number is exclusive, and the loop iterates through each value in the sequence. Unlike VBA, Python doesn't have a separate for each loop. Instead, its standard for loop is versatile enough to handle both scenarios. You can use it to iterate over various data structures such as lists and collections. You can also use the for loop to loop through a string. In contrast, reading through a string in VBA requires additional steps such as using the len and mid functions to extract characters one at a time. In conclusion, VBA has two distinct types of for loops, the standard for loop and the for each loop, each with specific advantages. Python simplifies this by using a single versatile for loop for all iteration tasks. In VBA we have two types of procedures. Type 1 is the sub procedure, which looks like this. A sub, which is short for subroutine, is used to perform a series of actions but does not return a value. The second type of procedure in VBA is a function. The key difference between the two is that only functions return values. Technically, you could use functions for everything in VBA, but subs are typically used for tasks that don't require a return value. Python, like most modern programming languages, uses only one type of procedure, the function. Functions in Python are defined using the def keyword followed by the function name and a colon. Unlike VBA, Python doesn't distinguish between procedures that return values and those that don't. All procedures are functions and they may or may not use the return statement depending on your needs. Note that Python requires all code inside a function to be indented to indicate which lines belong to the function. So they don't need an end function line like we have in VBA. In Python we return a value using the return keyword, and in VBA we return the value using the function name. In VBA we can call a procedure by using its name or by using the call keyword followed by the name. In Python we simply use the function name followed by parentheses. To return a value from a function is similar in both languages. We simply assign the variable to the name of the procedure. In both VBA and Python, parameters are passed to procedures or functions using commas to separate them. However, there are key differences in how parameters are handled. In Python, which is dynamically typed, there is no need to specify the variable type. In VBA, while it's optional to specify types, omitting them can lead to more errors and is less forgiving compared to Python. In VBA, anytime we use a procedure name to call it, then we don't use parentheses around the parameters. Conversely, if we use a call keyword or have any other keywords on the line, then we must use parentheses around the parameters. This is one of the most confusing aspects of the VBA language. A unique feature of Python is that you can write code outside of a function. This is useful for quick demonstrations or for small scripts. However, in professional or structured code, it's considered good practice to place this logic within functions. In VBA, we work with three main data structures: arrays, collections, and dictionaries, the latter being part of an external library. Here's a breakdown of their features and limitations. Arrays are extremely fast and versatile in VBA. For example, you can load a range of data into an array or write it back to the worksheet in a single line of code. They are compatible with many worksheet functions such as sum or the new Excel sort function. The drawbacks of arrays are that they lack built-in functionality found in most modern programming languages. They don't include methods for tasks like finding items, getting the length, cloning, and so on. You're limited to using the L-bound and U-bound functions, and these are used to get the upper and lower bounds of the array. Collections in VBA are rudimentary and can be thought of as an incomplete version of a dictionary. For most use cases, dictionaries are a better choice due to their superior features. Dictionaries are powerful but require adding a reference to the Microsoft Scripting runtime library or using create_object for better compatibility when distributing the code. So a major drawback of VBA's data structures is their inconsistency in design and usage. Arrays are declared using dim, and then they are resized using redim. Loops require L-bound and U-bound. With collections, they are created using the new keyword, and the loops run from 1 to the count method. With dictionaries, they're also created with the new keyword, but they can also be created using createObject. The loops range from 0 to count -1. These inconsistencies often lead to confusion among users, especially when switching between the different data structures. In Python, all the data structures have a consistent and intuitive syntax, and this makes them far easier to learn, use and understand compared to VBA's different approaches. Python has 4 main data structures. The first one, which is a list. A Python list is similar to a one-dimensional array in VBA, but comes with additional features and flexibility. We create a list like this using square parentheses. In Python, lists do not require a predefined size. You can add items dynamically without resizing. We can easily add to a list using append. We can also combine lists like this. And we can have a list of lists, which is equivalent to a two-dimensional array. One important thing to point out is that in VBA we use two-dimensional arrays with Excel ranges, but in Python we use data frames with ranges rather than lists. And this means that the list of lists are not as important in Python when it comes to using Excel. The list starts at position 0 and we can access items using the square bracket. One nice feature of Python is the way that we can slice data from a data structure. And we can do it very easily like this. The first number is the start position and the second number is the end position. The end position is not included in the slice. So here 0 is the first position of the slice and 2 is the last position. So this will return us the numbers 1, 2 and 3 from our list. To loop through a list is very simple. We simply use a for loop like this. In VBA we need to use a loop with debug print to print the contents of a data structure. But in Python the print statement doesn't require a loop. We can simply use it like this. Next we have tuples, which are pronounced tuple or tuple depending on who you ask. Tuples are essentially lists which are immutable. In other words, once they are created, they cannot be changed when the code is running. This is similar to how a constant variable works in VBA. The reason for using tuples is that they are more efficient with memory, and sometimes you want to make sure that the data of a list is not accidentally changed. You create them using the circular parentheses as opposed to the square one used by the list. Tuples can be used interchangeably with lists. In other words, we can assign a tuple to a list and vice versa. Tuples in Python support many of the same operations as lists and can be used in similar ways. For example, indexing. You can access the values in a tuple using an index just like with a list. Tuple support slicing, allowing you to extract specific portions in the same way as lists. And looping. Tuples can be iterated through using loops just as you would with a list. Dictionaries in Python are very similar to dictionaries in VBA. They are a key value data structure, and we create them like this. Here the item to the left of the colon is the key and the item to the right is the value. We can update or add a new item like this, which is very similar to how we would do it in VBA. And we can read through the items in a dictionary using a for loop like this. Sets are a collection of unique items. They automatically remove duplicates. You create a set using the curly brackets like this. Now imagine we had a list with the following items and you can see that we've multiple duplicates. We can automatically remove these duplicates by adding the values of the list to a set. Now when we print the set, it has no duplicates as you can see here. We can check a set to see if an item exists using the in keyword, and this is much faster than searching through a list. Sets are also very useful for performing operations like union and intersection. For example, imagine we have two sets like this. We can then create a third set, which is a union of these two sets. When we run the code, you can see that the new set is a union of the first two sets. We can read through a loop using the same loop syntax that we've used for other data structures. Now that we've seen the basics of the Python language, you may be curious as how to use it to interact with Excel. So Python offers two main ways to work with Excel. Number one, working directly with the Excel workbook files, and in this scenario there's no need for the Excel application. The number two method is interacting with the Excel application. So this is similar to VBA, and this involves working directly within Excel itself. Now if we're working directly with the files, then there are two main libraries that make this possible: Excel SX Writer and OpenPyXL. Now the Writer library is optimized for writing data to files. It's ideal for handling large data sets due to its fast write speeds. However, as the name suggests, it's limited to writing and cannot edit or read existing files. OpenPyXL, on the other hand, is the most popular library in this space. It provides a full range of functionality, allowing you to read, write and modify Excel files with ease. Let's dive into OpenPyXL and explore how you can use it to manage and manipulate Excel workbooks effectively. The first thing we must do is install the library. Now if you have installed Anaconda already, then the OpenPyXL library should be already there. Otherwise you need to install it from the command line using pip install OpenPyXL. So this is the Excel file that we'll be using. So you can see that it has some very simple data. Now let's see how we can perform basic Excel operations on the file using Python. We first of all import the OpenPyXL library, and we can then load our file using the load workbook method of OpenPyXL. And this will store the workbook object in the book variable. We can then access any worksheet in this workbook using square brackets and the name of the worksheet in quotes. We can read from cells using either of the following methods, and you can see that this is quite similar to how we do it in VBA using range and using cells. When we run this code, you can see that it printed out the values from cells A1 and B1. If we want to read through the data, then we first of all get the last row using the max row method of the sheet. We can then use the following loop to read through the data. When we run the code, you can see that it printed out all the values from column 1. If we wish to write values, we can do so like this. And you can see the result in the file here. Once we've finished updating our workbook, we obviously need to save it, and we can do so easily using the save method. If you're looking to interact directly with Excel using Python, you've got two popular options: PyXL and Excel Wings. PyXL is a paid tool, but it comes with a free 30-day trial to test it out. I haven't covered it so far, but I may do a video on it in the future. Excel Wings also has a paid version, but it offers a free option for basic use. I've covered Excel Wings in this video, so check it out if you want to learn more about using it. You might be looking at the previous OpenPyXL code and thinking, this feels pretty similar to what I can do with VBA, so what is the real advantage of using Python? And you're right, when it comes to data handling, the differences might not be immediately obvious. But that's where Pandas comes in. Pandas is a powerful library designed specifically for working with datasets, and it offers extensive, easy-to-use functionality that takes data manipulation to a whole new level. Let's dive into Pandas with this sample worksheet. This is the data that we'll be working with. To use Pandas, we must first import the Pandas library like this. We can then use the read Excel method to read our data into a data frame. One important thing to understand is that Pandas automatically adds an index column to our data for faster manipulation. Now that we've got our data loaded, let's see how Pandas makes working with it so much easier. The first step in working with data is cleaning it, and Pandas makes this process incredibly powerful and efficient. Two key tools for selecting and manipulating data in Pandas are lock and ilock. Lock is short for location, and ilock is short for integer location. Let's look at ilock first. It takes two parameters, row and column. Keep in mind that parameters are zero based, so 0 refers to row 1, 1 refers to row 2, and so on. We can retrieve the item in the first row and column by using a single integer for each parameter, like this. You can see that this returns Olivia Bennett, which is in position 00 in her data. Note that ilock ignores the header row and the index column. If we use 2 and 0, then iLock retrieves Sophia Martinez, which is in row 2 and column 0. This is pretty straightforward and works just like retrieving items from an array in VBA. But here's where iLock gets really powerful. It can do much more than just select single items. Here we supply a list of integers as the column parameters. This returns us the values in columns 1 and 3 from row 1. And you will notice that we also get the columns headers. In our next example, we supply a list of rows. This returns us the values from column 1 in rows 1 and 3. And you will notice that the index was returned as well. We can use the above methods together. We get the values from row 1 and 3 and columns 1 and 3 with the column headers and the row index. If we want to retrieve all the data in the second row, then we can supply the slice operator as the parameter. If we want to retrieve all the data in the second column, then we do this. If we want all the rows from position 3 to 5 with all the column data, then we do this. Note that row 6 is not included in the result. We're actually retrieving rows from position 3 to 5. And now if we want to get all the columns from position 3 to 5 with all the row data, then we can write it like this. So we can mix and match any of the options that we just looked at. And here you can see that we're using a list of integers for the row and we're using the slicing operator for the columns. And this retrieves row 1 and 5 and the columns 0 to 2. Lock retrieves values based on index labels and headers rather than their position. I have changed the index of the data so that there isn't confusion between the index and position. In our first example, we retrieve data from all rows in the history column. Our next example retrieves data from all columns in the row with index 1010. We can also use the list and slicing operators just like we did with iLock. In this example, we will retrieve the data in the biology to mathematics columns from rows with index 1004 and 1008. In VBA, if you want to filter data directly in the code, you typically need a for loop combined with an if statement. With Pandas, filtering data is much simpler and more powerful. Pandas gives you multiple ways to filter, but one of the easiest is using the query method. Here is an example. This line of code returns all the rows where the history and physics marks are less than 50. It's quick, clean, and doesn't require writing loops or complex conditions. Here is an example of retrieving data where the student name starts with E. Grouping data is a way of grouping specific items together and showing their totals, averages, etc. So a pivot table is an example of grouping data. Now, grouping in VBA requires using a dictionary and quite a bit of code. Using Pandas, we can easily group the data like this. You can see that we get the data grouped by fruit and the volume is summed for each of the fruits. Now in this example, we group by country and we can see the volume for each country. Joining tables is something that we often do with data, particularly in databases. In VBA, it's very complicated to do a join. We can use ADO and SQL, but that does require a certain amount of basic code and sometimes there is an issue with data conversion. Take a look at this data. We have a list of sales data which has a product ID. And if we look at the product table, we can see the ID and the details of the product. So our task is to join this data so we can create a report that shows the product name and the quantity for that product. So let's see how we'll do it. First of all, we load the data into our data frames for each of the tables. Next, we perform our join like this using merge. So this works similar to a join in SQL. So to get the product name and quantity columns, we use our friend lock. And when we run this code, you can see the final result. If you would like to learn more about setting up Python and using it with Excel, then check out this video.